When we are doing the asset allocation, the first step is we need to identify the return objective and as well as the risk objective for our client. In terms of return objective, it based on different your investors. Now, if for individual investor, right, for individual investor in the workforce, our return objective is pretty obvious. Is to provide an adequate retirement income. So for workforce individuals, the return objective is to provide adequate retirement income. For institution like endowment or foundation, what is our return objective? Our return objective, very important, is to maintain a fund's real purchasing power after distribution. For endowment and foundation, they have a distribution obligation. Like Universal Foundation, all right. If you have an endowment there, like endowed professor, their salary is from the endowment, and the endowment fund have to generate like say 5%, pretty much a guaranteed distribution. And in addition to meet the obligation, the return, when we talk about return objective for endowment or foundation, is to maintain their real purchasing power. In other words, it's not going to be affected by the inflation for the future distribution. So that is important when you answer the question in the test for address on different type of investor. Now, what about for pension plan and insurance company? All right. What is their return objective? Well, the return objective for these type of institutional investor, pension or insurance company, is to meet the or meet appropriate or adequately fund liability. So the focus return is to provide sufficient return to meet the liability. That is return objective. So we summarize that depending on different type of investor you are facing. But regardless, what type of investor, but there's one common objective for all investor is to generate excess return that can not only meet the inflation, but actually have some kind of alpha seeking. So the existing rate of inflation in the long term. All right. So have to more than the inflation. You want to generate some other type additional return. In addition to the requirement. So this is a requirement based on to meet the basic need as well as to generate some additional return. So in general, right, the return objective, when you calculate the return, we actually calculate the required return, all right, required return before tax adjusted by inflation. So the formulation is 1 plus the required return times the 1 plus inflation. This is the inflation adjusted holding required return, or holding period return required by investor, minus 1 is the required rate of return. Right? It's the required rate of return. So please memorize this. This is important. All right? Always, every question in the CFA exam had a focus on calculating about the return objective, the return based on the investor objective. All right. The next question is, what about risk objective? So how do we identify the risk? What type of risk? But we have to understand the objective. Risk objective is talk about what is the risk tolerance that investor have. Okay. Now, here is I give you two type of approach. Right. One is investors say, well, I want to do here is to maximize my utility, which is satisfaction function, but it's expected utility. So it's expected utility maximization. Now, Please be careful. It's expected utility, not the current utility. Okay. So basically, is to meet the satisfaction. Another one is to make uh, the minimum requirement return, which means safety first. I want to make sure that I'm safe. So it's more like loss aversion type approach to prevent the potential loss or caused by some kind of disaster. So safety first rule is one type of risk objective. Let's talk about the expect utility. Expect utility, how do we quantify that? That's the issue here. Here show you a formulation is that the UP hat, that means expect utility, is equal to the RP hat, that expect return on the portfolio, minus 0.005. 0.005 is one half of 1%. One half of 1% times A. A is the risk aversion score. Like it's a risk aversion. And then sigma square of P is the variance of the portfolio return. So in other words, the expected utility can be calculated by the expected return minus half of 1% times the risk aversion index times the variance of portfolio's return. Now here's some calculation, but I would like to spend a little bit of time to explain how do we get this equation here. I think it's not just memorized. We need to understand where does that come from. Here is the mathematical derivation. EUR, ease of UR is expected utility of return. By using the Taylor's expansion is equal to the U with utility of the mu. Mu is the expected return. All right. Mu is the expected return. So it's utility of the expected return plus the first derivative of the utility function with respect to mu times the expected return minus the mu. So this term is going to be 0. Mu is expected return, and then because it's minus the mu, expected return minus mu, so this term is 0. The next term is very important. U double prime is a second derivative of the utility function with respect to the mean return, mu, divided by half. So 1 half of the U double prime. The U double prime mu, the second derivative of a utility function, is called risk aversion. It's called the relative, this absolute risk aversion. It's a risk aversion. This number, because utility is concave, therefore this utility in the second derivative is a negative. All right, it's a negative. Now, the second term here is expect R minus mu squared. This is the variance. Statistically, this is the variance. It's called sigma squared. And then here is all the higher moment combination, like skewness, kurtosis, and so on. Okay. Now, to simplify this model, we assume the residual term here, all the high moment model approach to 0. High moment combination approach to 0 because it's very small. And then we actually make assumption there, the expect utility for the mean return, it is a mean return. So the expected mu, assuming it's a mean return. And then we let the negative value of u double prime, because u double prime is a negative number, less than 0. So we take a negative of the negative, the A absolute risk aversion here, it's a risk aversion, is a positive number. Then we actually put this thing into this model, the Taylor expansion, we have this result. The expected utility equal to the mean expected the expected return minus half of the risk aversion times the variance. All right, it's a mean return, expected return minus half of the risk aversion times the variance. That is the reason we get this result. The expected utility of portfolio is the expected return of portfolio minus half of 1% times absolute risk aversion times the variance of the portfolio return. Now we can apply that one to a case, small case, the allocation between two sector, two asset class, A and B, with a return 9.7%, and 7% expected return, standard deviation 15 and 10, and so on. Then we use this information and calculate the expected return. We find that the portfolio as allocation, the A portfolio, say here this is portfolio A, had a higher return than B. So if based on expected utility maximization, A will be preferred. Okay, so you will allocate more in A. Now, on the other approach, we talk about safety first rule. The safety first rule is more like very similar to like a Sharpe ratio, right? Like a Sharpe ratio. But this is safety first, but the Sharpe ratio using the risk-free rate, here we talk about is a minimum acceptable return. So there's a minimum acceptable return that the shareholder or the investor are looking for. All right, it's called a threshold return, minimum acceptable return. For example, the university foundation had endowment. The endowment need to be distributed, right? The principal need to be distributed like 5% as the maybe the endowed professor salary. That 5% is called the minimum acceptable return. The firm need to at least generate 5% to meet the obligation. Okay, to meet the obligation. Now, the Sharpe ratio used this way is say, well, what is the expected return you have to generate from the portfolio minus that the minimum acceptable return, but adjust by the volatility, standard deviation, which is square root of the variance. So this is a risk adjust additional return, all right, expected additional return, risk adjust. You wish to have this ratio as higher as possible. So that means you will have higher adjustable return, risk adjusted return. Now we use the same number and they calculate that. We find that portfolio B actually had higher SFR, higher the safety first rule return. So you see, well, that's different than the expected utility maximization, right? If you use the expected utility maximization, portfolio A is better than B. If you use safety first rule, B is than A. But we have different result, a conflict result. Then you ask the question, how come? Why? We have different result. Well, it depending on two things. One is risk aversion. Second, it depends on the minimum acceptable return. If you have a higher minimum acceptable return, or you have lower risk aversion, all right, or vice versa, you will have different result between these two approaches. So expect utility maximization, it will be significantly affected by risk aversion score, where the safety first rule will be affected by mainly the threshold return, or it's called the minimum acceptable return. So this will be very important because that will set up a different risk objective for your investors.